Morning, all of you. I am Dr.J.S.Lad, Head of Department of Physics. My roll number is 4. Refresher course in Foundation of Data Science. HRD Dr. Bamu, Marathwada University, Aurangabad. Micro teaching PPT, and my topic is Basic Probability. Introduction content. So, in a probability, event, sample space, and probability. Complement events, additive rule and mutually exclusive events, conditional probability, learning objective, that is development of a probability as a measure of uncertainty, introductive basic rule for finding the probabilities, use probability as a measure of reliability for an inference. Then we know that thinking a challenge of the probability. What is the probability of getting a head on the toss of a single pair of coin? Use a scale from 0 to 1. So toss of a coin twice. Do it. Did you get one head, one tail, and what's it all mean? Even sample space and probability is an experiment and sample space. Now first experiment to performing related to probability, process of observation that leads to a single outcome that cannot be predicted with uncertainty, and it is related with sample space and depends upon experimenter. Simple point, most basic outcome of an event, sample space, depends upon experiment. Sample space yes, and collection of all possible outcomes. Then visualizing a simple space, listening, set yes is equal to head comma tail, and Venn diagram H, T and yes. Simple space example, experiment and sample space, toss of a coin, note a face, and sample space is head comma tail. Toss of two coins, note space HH comma ST comma TH comma TT. Select a card, note a kind, 2 up to A, and it is related with 52. Select a one card, note a color, red or black. Play a football game, win, lose and tie. Inspect a part, note a quality and defective good. Observe a gender, male and female. Now we will discuss the events. Now first, specific collection of a sample point. Simple event contains only one sample point. Also third point is compound event. It contains two or more sample points. Now Venn diagram for the experiment, toss of two coins, note space, and then the sample space is represented by rectangular diagram. S is equal to HH, HT, TH, TT. In a compound event, at least one tail, and outcome is represented by HH. Sample space is represented by rectangle space, and S is a sample space, and HH, TH, HT and TT be the possibilities. Now event example, experiment, toss two coins, note a space, sample space HH, TT, TH, TT. Event one head and one tail, and outcomes in the event is HT, TH. Then head on the first coin is HH, HT. At a least one head HH, HT, TH. Head on a both HH. Then probabilities. What is probability? Numerical measure of the likelihood that event will be occur, that is P of event, PA and probable A. Then lies between 0 and 1 is a probability 1, 0.5 and 0, certain and impossible, lies between 0 and 1. Sum of the sample point is 1. Then probability rule for a sample points, let Pi represent the probability of a sample point I. All sample point probability must lies between 0 and 1, that is 0 is less than Pi is less than 1. The probability of all sample points within a sample space must sum to 1, that is summation of Pi is equal to 1. Equally likely probabilities. Now P event is equal to X by T, where X is equal to number of outcomes in the event, T is equal to total number of sample point in the sample space, and each of the T sample point is equally likely, and P sample point is equal to 1 by T. Then steps for calculating the probability. Define the experiment, describe the process used to make an observation and the type of observation that will be recorded. List the sample points, assign the probability of a sample points, determine the collection of a sample point contained in the event of the interest, sum the sample points probability to get the event probability, and combination rule which is related with probability. A sample of n element is to be drawn from a set of n element. The number of different sample possible is denoted by in bracket capital N small n and is equal to capital N small n is equal to ni factorial n factorial upon n factorial in bracket n minus small n factorial, where the factorial symbol is represented by that, and ni factorial is equal to n into n minus 1 into n minus 2 into L into 3 into 2 into 1. And for example, 5 factorial is equal to 5 into 4 into 3 into 2 into 1, where 0 factorial is defined to be a 1. Now compound events. What is the compound event and can be explained by the probabilities related? The combination of two or more events can be formed in two different ways. Union of intersection. Now first union, outcomes in either event A or B or both. Second OR statement, and third denoted by union symbol, that is A intersection B. Then interaction, outcome in the both event A and B, and A and statement denoted by symbol. Therefore A and B. The compound event probability, numerical measure of likelihood that compound event will occur. Second, can offer use two-way table, two variables only, conditional probabilities. The conditional probability, it is related with event, and therefore event probability is given that another event occurred. Revise original sample space to account for a new information and eliminates a certain outcomes. Now we know that the conditional probability of mathematical statement, and that formula is represented by P of P in bracket A by B is equal to P A and B upon PB, that is equal to P of A and B upon PB. This is the mathematical formula for conditional probability, and therefore conditional probability using a Venn diagram. Now see here, in a black happens, eliminate all other reactions. Therefore the event S black and yes, and therefore the event S and black. Thank you very much all of you. We shall stop here.